Hey ho, I show you all available data of chlorophyll profile. Okay, starting in the top left corner is February 2011. And you can see there's something like 6 profiles. So we don't have many observations in some years. Some years only have a few, 3 profiles. Some years like February 2012 have many profiles. But however, let's have a look at it. Let's have a look at that. You can see, and they all have the same horizontal axis range. That's the important thing if you make comparison. Yeah, you can see the range is always from 0 to 2 milligrams per cubic meter in chlorophyll A. So just by looking from one to the next, you can make comparisons. So for example, in 2011, this is in February, you can see that there are peaks exceeding 1 milligrams per cubic meter. 2012, yes. 2013, well, it doesn't reach 1, but it's 0.8. Okay? And you can see there are some. You know, you get the most. 2016, there is a little bit of, not really. In 2018, but we don't know whether they're actually just shifted spatially. 2019, February 2020, well, not. Anyway, you can see that there are subsurface blooms every year in the Eastern Great Australian Bight. There are regular feature, and indeed you can also look at 2013 again. 2013, it's a year where you had all warm water from the South Australian Current. And that's the idea, actually. So warm water coming in, suppressing the formation of the Kangaroo Island pool. But you still had sufficient nutrients in the system, still sufficiently high levels of chlorophyll A, so that you can still maintain a sufficient growth of sardines, which are shown here in this map. This is a repeat. Although there's a little drop of the spawning biomass, there is still sufficient nutrients in the system. Okay, so now we actually think that we know how this marine ecosystem works. It's the functioning of that entire ecosystem. Okay, so summary. New research findings strongly suggest that the large marine ecosystem of the Eastern Great Australian Bight is driven by subsurface rather than surface phytoplankton. It's created via the classical wind-driven Ekman upwelling, fueled with dissolved nutrients from the Ki pool. So the early arrival of the warm and nutrient-poor South Australian Current has the potential to suppress formation of the Ki. And that should be the focus of future studies. Okay, because everybody talks about global warming. What is the effect of global warming on the upwelling? We looked at wind data. There are no noticeable changes in the wind forcing. We looked at the variability of the Ki pool. And so the only real variability that we could clearly identify is linked to the South Australian Current. Okay, so what will happen in the future? That's the big question to the South Australian Current. So there is some link and some first idea links to climate change. All rightio. Thanks for watching. Okay, enjoy the Christmas time. Thanks for your grandma and your neighbors. And I hope that you have a party now, all right? Cheerio.